the resistor R, when you go to Laplace, it will stay the same. The inductor L, when you go to Laplace, you have two choices for that, for the inductor. I'm taking this out of our book. You can replace it with the inductor of the value of S sub L with a value minus to plus L I sub 0, or you can replace it with this circuit of SC, or SL, not SC, SL with the current down, we just derived that one, of I sub 0 over S. You have a choice. Which one makes it easy? When you have a capacitor, the Laplace of that will be 1 over SC. We did this one. With the voltage source of V0 minus, or V0 over S. That's the integral one. Or you can replace it with 1 over SC with the current source that's pointing upward of the value CV0. That's your equivalent in Laplace. You can go to Laplace of the derivative, the Laplace of the integral, and apply them, but that's what you're going to end up with. Now, if we're lucky, our initial condition is 0. If our initial condition is 0, Laplace of L is SL. The Laplace of C, 1 over SC. And you're done. But you'll see some problem where it's not really 0. So let's take an example and see what we have. Here's an example. Let's see if I can find a good example. I got a couple of them. I'll start with a not bad one for now. Then I'll make it more complicated, or a little bit bigger. 4e to the minus 2t. And u sub t, that means you really have a switch here, and the switch closes at t equals to 0. That's what you have. You have a value of 1/3 farad capacitor here. You have a resistor here of 10 ohms. You have an inductor of 4 Henry, and you have a voltage source here of 2 e to the minus t, u sub t. Again, that was a switch here, close at t equals to 0, but instead of putting switches, we use u sub t. Notice here, these are different functions. Normally, when you have a problem like this, e to the minus 2t, e to the minus t, if you were doing by hand, you'll use what? In time domain superposition. But I don't have to. The process here to take this circuit, the first step, and find the Laplace of that. Here's the good news. Since the circuit has no power for t less than 0, what is the current through the inductor? What's I sub L is 0 minus? 0. What's the voltage across the capacitor? 0 minus 0. There's nothing there. Now let's look at this. What's the Laplace of 4e to the minus 2t? 4 over, is it s plus 2? Now, here we go. The Laplace of a capacitor, since the initial conditions are 0, either way is going to be 1 over SC. The 10 ohm stays 10.
Isn't that just
J omega. Yes. Well, we'll put the, we'll put the number. And this one will be what? Just SL, no initial condition. Notice I sub 0, 0, this is gone or this is gone. And the Laplace of this will be minus to plus what? 2 over S plus 1. Let's plug in the value for C. We say 1/3. That's 3 over S. That's 10. I'm not even drawing pictures anymore, like capacitors, inductors. And this is what? 4S over S plus 1. And we need to solve that. I forgot what the question for this problem. Find I sub 1, I sub 2. I sub 1 is this current. I sub 2 is that current. I sub 1, I sub 2. What are they? That's what the question. Remember the process we said. We said we're going to take the circuit from time domain, change it to Laplace. We're going to solve it in Laplace, then change it back to time domain. Let's solve it in Laplace. We can do KVL here, 2 equations by 2 unknowns. Here's the first equation, minus to plus, minus 4 over S plus 2 plus 3 over S times I sub 1 as a function of S plus 10 times, what's the current coming down? 1 minus 2. So clean it. 10 plus 3 over S times I sub 1 minus 10 times I sub 2 equals 4 over S plus 2. That's equation 1.
What are we using as S, or are we just putting that S into the calculator?
You can plug in X at the end and see what the answer of the calculator will do it.
It should.
I didn't try it on my calculator yet. Second equation right here. Negative 2 over S plus 1 plus 10 times I sub 2 minus I sub 1 plus 4S times what? 4S times I sub 2 is equal to 0. Clean it. Negative 10 I sub 1 plus 4S plus 10 I sub 2 equals 2 over S plus 1. And again, that's equation number 2. And I need to solve for I sub 1 and I sub 2 and see what we have.
We have 3 unknowns though.
2 unknowns, I sub 1, I sub 2.
You're leaving S in.
You find your answer in terms of S.
Really?
Then you get the inverse Laplace of that.
That makes so much sense.
Huh?
That makes so
Yep.
much sense.
You leave it in terms of S. I am not sure if my calculator
Oh my gosh.
Can it solve it? It should be ugly one.
It's absurdly ugly.
I was thinking like.
What's I sub 1? What do you got there?
Okay, ready for I sub 1?
I mean, if you had it
This'll-
in approximate, it'd probably be better.
No, give the exact one. What was I sub
It's
s?
messy.
0.4 times s times parentheses times s to the power of 2 plus 4.75 times s plus 5.
Okay, well, I cleaned it better actually. I got 2s,
Do you have a, wait, let me check mine.
4s squared. I didn't divide by 19s.
I have approximate. You said you wanted exact?
Exact, yep.
Let me see if exact does better.
20s to the 4th.
Yeah,
Oh, no, yeah, it's got it.
20s to the 4th.
Yeah, it's just factored it differently. but
Yep.
It's the same thing.
66. Did they factor this one for you?
Yeah, factor the denominator, the top's the exact.
Oh, wait, good. I like that. The factors that. 73s squared plus 57s plus 30. So what did our calculator give just for the bottom, for I sub 1?
For I sub 2.
No, I sub 1, just when you factor the bottom. Let me just write the top.
bottom, s plus 1.
Wait, let me just write this. Over, was it s plus 1?
Times s plus 2 times 20 s to the power of 2 times 6s plus 15.
Plus 6s
Yes.
Yep, that's what I read.
plus 15. So even factor that for us. And what about I sub 2? That's nice, actually. The calculator can do that. Now I'll show the people on the camera how to do it in a second there. I sub 2. The bottom is going to be the same. Yep. The top will be different.
30s to the power of 2.
30s squared
Yep.
plus 43s
43. Yep.
plus the 6.
I have plus 20.
I got plus a 6.
Oh, sorry.
6?
sorry.
Yep. So here's what you do on the calculator. If you have a TI-89, you go to apps and solving simultaneous equation right there. 2 equations by 2 unknowns, new one. 2 equations by 2 unknowns. And you put in the values for them. What values? Right here. There's the first equation. Negative 10. 4s plus 10. I can go 4x plus 10 instead of 4s. And this one, 2 divided by parentheses x plus 1. I'm using x again in place of s. Oh, wait a minute. Did I use the right one? Yep. That's really my second equation. My first one is this one. 10 plus 3 over x. Negative 10. 4 divided by parentheses x plus 2. Graph. I mean, solve. F5, not graph. Busy, 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 busy.
I did it rather quickly.
Oh, you know what? It looks like I typed the last one wrong here. I didn't put a minus. Oh, maybe I did.
Maybe you have. Mine was also an exact, not an approximate.
And I think mine's an exact. Oh no, it was approximate. So let me go back to mode. Where is it? Make sure I'm in exact mode. As I said, I want to be in exact mode. Where is exact? Is that approximate? Ask for exact. And now it's going to do it. There we go. 2x times 4x squared plus 19x plus 20. That's the top here. Divided by, if you want to see it, here we go. s plus 1, s plus 2, 20s squared plus 6s plus the 15. And if you look at the second one, second one was 30x squared, right here. 30x squared plus 43s plus 6 divided by the same thing in the bottom. That makes my life a little bit easier. I don't have to do the math, nothing. And now I gotta solve for I1, I sub 2. So take the circuit from time domain, change it to Laplace, we did that. Solve it in Laplace, we did that. And now change it back to time domain. Step number 3. So now take the inverse Laplace. Well, let's look at I sub 1 first. Then we'll do I sub 2. I sub 1 in Laplace. So what is the inverse Laplace of I sub 1, which is 24 4s squared plus 19s plus 20 over s plus 1,
It's a 2s on the outside and a 20.
Yeah.
2s, yeah, 2s, not 24. It is 2s, thank you. I have 2s, I just wrote 24. S plus 1, s plus 2, 20s squared plus 6s plus 15. And again, the way we're going to do this, we're going to break it down to k1 over s plus 1, k2 over s plus 2, and the other one. So here's how I'm going to break it down. This is going to be k1 over s plus 1, k2 over s plus 2. And if you remember, the way I did the quadratic a little bit different than math. I found the roots for this, and I used the shortcut. So I said, okay, if I want to solve this equation, the quadratic, right here, s will be negative b, negative 6, plus or minus the square root of 36, minus 4 times 8, 4ac, 60 times 20. What's 60 times 20? 1200, is it? 60 times 20, escape. Here we go. Clear. 4ac, 4 times 15 times 20. 1200, yep. All divided by 2a, which is what? What's 2a? 40. I'm going to divide that by 40. So if you do that, that's negative 6 plus plus I or j, 1200 minus 36, 1164. Take the square root of that number. Where's the square root of that number? Square root, where'd you go? To the power of 0.5. Make my life easy.
I got 2 times.
Yeah, let me change it back to exact value. I mean approximation here. Mode, I don't want to carry these crazy numbers now. Let's go back to approximation. Otherwise,
4.1.
5.84 divided by 40.
I do not have 5.84.
No? Let me try it again. The square root.
It doesn't even sound right. You're trying to get to 1164.
The square, yeah, it can't be. The square root of 1164. I probably did the square root of the square root. 34.1.
Yeah, that makes sense. I was just like,
Yeah. Yeah, 5, yeah. That's 11 something. That's 34.12. So you divide it by negative 40. Here we go. 6 divided by 40. Is that 1.5? Yep. Negative 0.15 plus or minus j 34.12 divided by 40.853. So when you write that, you can write that plus K3 over S plus 0.15 minus J 0.853 plus K3 conjugate over S plus 0.15 minus plus J 0.853. And I can use my shortcut that I learned last class, how to find K1, K2, and K3. K1 is going to be what? Notice sitting on top of S plus 1. Cover S plus 1. So if people are looking for like a nice quick way to solve them, you still don't have one. You probably will never have one for a problem like this.
Never's a long time.
Unless you have an easy problem, a simple.
Like this one.
Plug it when S equals -1. So what are we going to have? That's a -2 on the top. That's 4 minus 19. What's 4 minus 19 plus 20? 4 plus 1 is 5. -1 plus 2 is what? 1? 20. 35. 35 minus 6 is what? 29? -10 over 29. Bless you. Again, double check these numbers just to make sure. This is 24 minus 19. 24, that's minus 19 is what? 5. This is -2. This is 1. 35 minus 6. 35 minus 29, 10 over 29. So that'll be a small number. 10 divided by 29, 0.345. Or 345 milli, if you want to use milli. We'll see. K2. K2 sitting on top of S plus 2. S plus 2 is gone now. So be S plus 1 in the bottom. 20S squared plus 6S plus the 15. S equals -2. Plug it in. -4. That's 4 here. 4 times 4 is 16. 16 and 20. What's 16 and 20? 36? 36 minus 38. Is that -2? 36 minus 38 over -1. 4 times 20. 80. 95. 95 minus 12. What's 95 minus 12?
83.
That's 8 over, will be -8 over 83. .096 or 96 milli. Negative, right? Don't forget the negative. That's negative here too. I forgot the negative sign. I'm too excited about them. Now K3. Notice you can take this bottom and write it as this times that. So this here is this times that. So if I'm looking for K3, this is going to be 2s 4s squared plus 19s plus 20 over s plus 1, s plus 2. You're going to replace this with this times that. Since this is going to be gone, so what you have left is s plus 0.15 plus j 0.853. And you want to find that when s equals what? When is this one going to be 0? Negative 0.15 plus j 0.853. Good luck to all of us. God bless us.
Wait, isn't that minus J?
Nope. When you move it to this side, this becomes a minus to solve for it. That's a plus. So let's plug them in and see what that answer. Oh, that looks wonderful. Let me look at the top alone. Let's see if I can get the top first. 2 times parentheses 0.15 plus 0.853 I times parentheses, 2 sets of parentheses. Well, I'll do one. 4 times parentheses 0.15. Oh, that's a negative 0.15, right?
Yes.
I gotta go back and insert negative here. Where's insert? Insert button. Yep, negative 0.15. Negative 0.15 plus 0.853 I, square that, plus 19 times that, parentheses, negative 0.15 plus 0.853 I. Imagine if you don't have a calculator there. Plus 20, close that. The top says something is missing, escape. I must have one less bracket. Oh, I forgot the 2 times. 2 times parentheses negative 0.15 plus 0.35 yep, times 4 negative 0.15 squared plus 19 times negative 0.15 plus 20, enter. I got an answer for the top. 36.16 angle 146. Anyone get that answer?
I have 40.8 angle 146.
Just for the top alone.
I have 40.8.
So we disagree on that. So somebody will have
The
a...
angle is basically the same.
Yep. So somebody double check that just to make sure the numbers are matching. Let's look at the bottom. Replace S with that. So negative 0.15 plus 1. Here we go. Negative 0.15 plus 0.853I plus the 1 times negative 0.15 plus 0.853I plus 2 times the 0.15 will cancel each other out. 2 times that number. 2 times 0.853I. The bottom, 4.185 angle 159.9.
I rounded, but yeah, I got 4.2 angle 160.
So when we divide them, if I did this correctly, if the top is correct, again, I'm not claiming my top is correct here. If it is correct, you divide the two numbers, double check your calculator, verify the numbers. I got K3 equals 8.64 angle negative 13.2. What do you got for a number there? Anyone got a different answer?
Well, I was using the 140, but
So you got,
40. Sorry, but
so what do you got for an answer here when you divide them?
9.71 angle negative 16.5.
Negative 16.5. Okay. So we disagree a little bit on that number there. Again, plug them in, assuming my numbers are correct. And again, I could be wrong, and I wouldn't doubt it. If my numbers are correct, now we do the inverse Laplace. What is I sub 1 as a function of time? What is the inverse Laplace of k1 over s plus 1? k1 is negative, so negative 0.345. The inverse Laplace of 1 over s plus 1, e to the minus t. Minus k2, 0.096. The inverse Laplace of 1 over s plus 2, e to the minus 2t. Now remember the equation for this. This will be what? 2 times the absolute value of k, in case you forgot. E to the minus alpha t. We wrote alpha, right? Last time. Cosine beta t plus theta. Is that the equation we wrote? So what is I sub 1? Two times alpha. Alpha is, this is your alpha, this is your beta. 2 times 8.64. 2 times 8.64.
17.28.
17.28. Oh, 2k. K, yep. That's k, not alpha. That's theta. This is k, sorry. This is k, and this is theta. 2 times k, e to the minus alpha. What's alpha? Alpha is negative 0.15. Cosine beta. This is alpha and this is beta. Beta is what? 0.853t plus theta, which is negative 13.2 degrees.
Let's do it again.
Then you gotta do for I sub 2. I'll let you have fun with that. Let me try another one, another example. See if I can make it a bit bigger. I got 15 minutes to squeeze in another ugly one.
Are they typically going to be different sources?
Well, they don't have to. It could be just one source. You know?
Yeah.
And notice for all these problems, I'm making the initial condition 0. I'm just looking to see if I have anything. So let's go back to what we did in circuits 1. Let me take an example from circuits 1 and show you how we do it now. We've done a problem like this. This is 32 volts. T equals to 0. You have a resistor of 0.96. We have an inductor of 0.8 Henry. This is not going to be like, earlier someone said I'm going to give you a harder one, but this is not the case. I changed my mind. I figured I'll go back to circuits 1. And we had a problem like this. 1.25, remember that? We had to look at the circuit for t less than 0 and find the initial conditions. Well, for t less than 0, the circuit's open. So I sub L through the inductor is 0. The voltage across the capacitor is also 0. I like it when it's 0 because my initial conditions, when you go back to this equation, the initial conditions are gone. It makes the problem even smaller. If these are not 0, the problem will get ugly. You will see that where this is not 0 coming up soon. Not today. Maybe the next video. If you remember, we did these a long time ago, 4 months ago, 5 months ago. We have to write a second order differential equation like this one and see if alpha is less than W and see which one of these is the correct answer. Underdamped, overdamped, critically damped. And go through that. And there used to be 4 or 5 pages of notes. Well, this is probably still going to be 4 or 5 pages of notes.
But at least you can follow it.
Yep, the same set of rules. Change it to Laplace. That's the first step. What's the Laplace of 32? 32 over S. The resistor stays the same. 0.96. The inductor SL. 0.8 S. The capacitor is 1 over SC. What is 1 divided by 1.25? 0.8 over S. And the question, find I sub 1.
Good old mesh. Always there.
That's it. So hopefully this won't be bad, the math. Don't count on it. Plug it in. Negative 32 over S plus 0.96 times I sub 1 plus 0.8 S I sub 1 plus 0.8 over S times I sub 1. I'm not a fan of fractions, so guess what? I will multiply, before I do anything, multiply everything by S to get rid of the fractions. Negative 32 plus 0.96 S I sub 1 plus 0.8 S squared I sub 1 plus 0.8 I sub 1 is equal to 0. Actually, this is not a bad problem, turned out to be. 0.8 S squared plus 0.96 S plus 0.8 You know what? I don't like that 0.8. What about if we divide everything by 0.8? Would that make the numbers better?
Well, that all depends on 0.96.
You end up with S squared. 0.96 divided by 0.8.
0.2.
1.2 S plus 1. 32 divided by 0.8, is it 40? Yep, 40. So what is I sub 1 as a function of S? I should start with this earlier, huh? And if I can factor that, I'm in good shape.
Negative 1.2.
So I'm going to find the roots for that one. Negative 1.25 plus or minus the square root of 1.25, 1.2. That's not 1.25, right? That's 1.2 s.
Yes.
My s is in my 5, so I never. So 1.2 square, 2.4 I think,
44
1.44
s squared.
minus
S squared. S squared. 1.44 s squared.
y squared.
Because
You only solve for s, right? You don't put the s's, you're solving for s.
Yeah.
1.44 minus 4ac divided by 2a. Take the square root of that answer. Or is the square root?
You know, when I solved as a fraction, it came out pretty nice.
Is it?
Yeah. Like all whole numbers and everything.
This will be 1.6. The numbers won't be bad, actually, even with this. So a negative, what's that, negative 0.6? Plus or minus what? 0.8? So when you take this one, you can write I sub 1 really as k over s plus 0.6 minus 0.8j. I forgot to write the j here. Plus k conjugate s plus 0.6 plus 0.8j. This is going to be much, much quicker this way. Way quicker than we did in circuits 1. Once I find k, I'm done with it. How do you find k? K equals, here we go, 40 over s plus 0.6 plus j 0.8. When what? When s equals negative 0.6 plus j 0.8. Negative, so the 0.6 will cancel 1.6j. That's it. 40 divided by 1.6 I or j. That's 25 angle negative 9. Is that what you got there? Alright. So once you get that, this is your k, this is your theta, this is your alpha, this is your beta. So your solution, I sub 1 as a function of time.
I have positive 90.
That's 1.6j in the bottom. Has to be negative 90. It's not negative, positive 1.6.
Yeah, that's what I'm saying.
Mm.
Is my calculator saying?
Unless you have a negative here.
Oh, no, it needs to be in
Here.
parentheses.
So now, this will be 2 times k e to the minus alpha t cosine beta t plus theta. So what's my answer? 2 times k. K is what? 25. E to the negative 0.6 t cosine beta, which is 0.8 t minus 90 degrees.
Would that be a positive 0.6 t, because you've got a negative 0.6 as your alpha?
Alpha is actually just the negative there. Yep. So that's 50 e to the negative 0.6 t cosine, because you have a plus and minus for these, so I just look at, notice how beta is always 0.8, alpha is the 0.6 there. Cosine 0.8 t minus 90 degrees. Now, what some books might do here, because that's a negative 90 degrees, right? So they might make it 50 e to the negative 0.6t. Instead of cosine, that's what? Sine. Right? Because what's the difference between sine cosine? Shifting of how much? 90 degrees. Now, if we had to do this the old method, that would have been probably 3 pages, 4 pages long. And it looks like it. We have this type of problem, underdamped. If you remember, we had to look at the derivative from the picture, the graph, the derivative from the equation, and look for K1, K2 to our solve. That wasn't easy when we get to that section. This one's much quicker, and it took us 15 minutes to do. That was it. Normally, that would take us the entire class using the time domain. We lucked out with the inverse, finding IC1. That was straightforward. The previous one wasn't pretty. I could have made this the first one and the other one the second one to start with. But you never know. You look at the problem, oh, that looks like straightforward. It looks like it till you get into the math. What happens if the initial conditions are not 0? Then we get a bigger problem. So we'll deal with that next time. Well, not bigger, but the math gets ugly. We have a test tomorrow.